All right, so we are covering up EIGRP. Okay, one second. Yep. Okay. So there was some issue with the pointer. Fine. So we are covering day two of EIGRP. Okay. So from the previous class, we gone through a lot of theory topics of EIGRP. Today I'll be covering more of labs. Okay. So just a quick revision. EIGRP is called as distance vector. Okay. So RIP and EIGRP. When you compare RIP and EIGRP, RIP is going to consider distance vector or a distance based on distance, but they are not very smart enough protocol. Okay, in case of EIGRP, along with distance, it's going to check multiple factor of those individual links. For example, it's going to see what is a bandwidth, what is the delay of an interface, it's going to see how reliable are they, what is the load on that link, and based on that the distance or the best path will be selected. Okay, so we have a component called metric, which is also called as cost, and based of cost we are going to see which is the best path. Okay, and from our previous class we have checked what is the command or what is the formula to calculate the metric in the case of EIGRP. So this is the complete formula. Okay, so this is your whole formula in the case of EIGRP, but by default the values of few of the k values will be set to 0. Okay, that's how your EIGRP is defined in the iOS. Okay, it's not that I am going to turn it off. It's your software which by default is considering few of the factors as 0. For example, these highlighted k values will be set up as 0. Okay, so in short this formula reduces just to bandwidth and metrics. Okay, so in short it's just going to be bandwidth plus delay, which has to be multiplied with 256 from the main formula. Okay, so I'll also show you the default behavior. So let's say on my device, okay, let's say I'm just running some device. Okay, so if I go and check show IP protocol, if I only see the k values, okay, so it will show me the default k values of my EIGRP. Okay, so by default the k2 value, k4, k5 will be set as 0 by my Cisco software. It will be only powered on for k1 and k3. That's why the formula whole together reduced to just bandwidth and delay. Okay, so it's not that I am going to put it as 0. It's your Cisco software, the iOS, which has put it already in 0. But yes, you can change the value. Okay, let's say you have some requirement, you want to manipulate uh, the EIGRP behavior. Yes, you can just play around with these k values, but by default they are zeros, and that's why we also calculated in the previous class how do we find the metrics or what is the cost value when let's say this is the bandwidth given and the bandwidth and the delay given, we just found out the metric. Okay, fine. So what else did we cover, or what else did we see in the previous class? Okay, so these were all the key points about EIGRP. By default, AD is 90 for internal EIGRP, external EIGRP is 170. By default, it's going to support 100 hop counts. In case of RIP, it is 16. In case of EIGRP, it is 100, but we can change it to 255. Okay, EIGRP is going to support equal load balancing as well as unequal load sharing or unequal load sharing. Okay, so we will do that lab as well. I'll show you how we do that. And regards to the hello and dead timer, by default it is 5 second for the hello timer and 15 second for the dead. Okay, and this don't have to be same. The hello and dead don't need to be same to establish a successful neighborship. So let's say I have 5 and 15. I can just keep it 3 and 9. Okay, so still they will form a neighborship in the case of EIGRP. And yes, what is how is hello and dead differentiated, or what is the formula? So basically it is 3 times of your hello packet, so into 3. That's how you get your hello packet. But yes, you can customize it. It's recommended to have into 3. Okay, the multicast IP here in case of EIGRP is 224.0.0.10. Okay, it supports authentication, MD5, and auto summarization is enabled by default. But we will also see the manual summarization today. Okay. Okay. Regards to the advantages, which is already discussed, the basic theory was discussed in the previous class. Okay. There are some EIGRP facts like how do you change the hello intervals, or the hello and dead interval relationship. Okay, or what is the command to see the packets and all those things. Okay, so we also checked EIGRP packet types. There are a couple of packet types. Okay, so hello is to build the initial neighborship, and later on it will be more on update and query. Okay, update, query, and acknowledgement in case a link neighborship is down and you want to have the second link coming up, so a update will be sent, or might be a query link will be sent. Okay, in case of new addition or a deletion of any network, now the update packet will be sent. So basis on the scenarios, the packets will be used. Okay, so these are the few packets that is supported in the EIGRP. This is the neighborship states. So first, when you enable EIGRP across both the router, a multicast packet will be sent. The second router is going to send the unicast packet with the complete routing table. Okay, and the first router is going to acknowledge back. And now the second router, or the R2, is going to send the hello packet. Okay, so this is again something which we discussed. This is a multicast. These are two unicast packet, once again multicast, and then again the unicast packet. Okay, the initial neighborship in the case of EIGRP. This is the same thing which we discussed. It's so what is the first thing happening here? It's a neighborship discovery. Later on, in the case of EIGRP, it's maintaining a different table called topology table. Okay, and what is topology table consisting of? A backup route. In case the primary route gets down, you still have the you still have the backup path which will be put up in the routing table. Okay, fine. This is regards to the metric calculation. Okay, EIGRP metric calculation. So uh, so let's say this diagram was being considered along with bandwidth and the delay given up here. Okay, and I told you what would be the scenario in this case, whether it will take up over via router 4, or whether it's going to take router 3. Okay, so basically it all depends on the metric, the cost to reach this network. Okay, so that was discussed in the previous class, and it was concluded that it will take router 3 as a best path because of the cost value, which is lesser than the other path. Okay, but the other path will not be discarded in the case of EIGRP. It will be put up in the topology table, and it will be acting as a feasible successor or a backup path. Okay, And then we discussed about EIGRP table. The same EIGRP table are nothing but neighbor topology routing table. The explanation of each component, what is SRTT, what is RTO, okay, what is what are the component of the topology table, and then we discussed about routing table components, okay. EIGRP metrics. So this is how you see the default K values, okay, with the command show IP protocols. Metric calculation, EIGRP named configuration. Well, this was not discussed, I guess, in the previous class. So let me tell you, by default, EIGRP can be configured in two ways. One is called as classic mode, okay, that's with the help of command router, EIGRP, and the autonomous system. Let's say that's called as classic mode. There is one more way we can configure EIGRP, and that is called as named mode, okay. So we just can name and we can just configure this, okay. So I'll show you this in today's lab, how do we configure the named configuration, okay. So it's given over here. Instead of autonomous system, you just have to give a random word, and then you need to configure address family, and you have to define whether it's a IPv4 or IPv6, and then there's where you give the autonomous system and the network, okay. So few extra things, but yes, this is also uh, been done in some organization, okay. So named is for your understanding. Even when you discuss about the access list, ACLs, you have two ways. One is the normal legacy way, which is called as numbered, and the other way is named, okay, for identification purpose. So similar way, in case of EIGRP, you have two ways. One is number way and the named way. Then there is a path selection optimization, which we will do a lab today, okay. There are some terminologies in case of EIGRP, which is called as advertised distance or reported distance, feasible distance, successor, feasible successor, okay. So if you make use of this command show IP EIGRP topology, you can see all the components, okay. So reported distance or advertised distance is the cost from the neighbor, okay. So let's say I have a network diagram in this way, okay. So let's say I have to reach 4.4.4 from 1.1.1, okay. So my packet can travel this way or my packet can travel this way. So let's say after the metric calculation, my preferred was this, okay. Now in this case, AD or feasible or the reported distance is the metric that is from here to here, okay. Cost from neighbor to destination. Who is a neighbor for me? This is the person who is acting as a neighbor. So this distance will be called as advertised distance or reported distance, okay. Feasible distance. Feasible distance is starting from here, starting from the source to destination. The complete metric from source to destination will be called as feasible distance. So always feasible distance will be greater than your AD or RD, okay. So because feasible distance is something which is from source to destination, which will be a greater value, right? Let's say if you have 10 on every hops, okay. So your AD will be 10 plus 10 plus 10, which is 30. In the case of FT, which is feasible distance, it's starting from here. So you just have to add one more 10, which becomes 40. Now FT is always higher than AD, okay. What is successor now? Successor is the best path. In the case of EIGRP, the best primary route which will be put up in the routing table is called as successor, okay, the primary route. Now what is feasible successor? The backup route, okay. So in this case, in my scenario which I have shown over here, this becomes feasible or a primary route, which will be put up in the routing table. The second route, which is acting as a backup route, which will be put up in the topology table of my EIGRP, okay, and which will be used later on during the reconvergence time. Okay, the same thing, which is once again discussed: feasible distance, reported distance, and feasible successor. Okay. EIGRP summarization, which I told there are two types. One is auto summarization, the other one is manual summarization. By default, auto will be enabled. So basically what is happening is, instead of advertising individual network, I would be sending the whole network in terms of /16, a broad network. Okay, now my prefix will be 192.168.0.0. Okay, the whole bunch of individual network don't need to be advertised every time. Okay, they are just increasing the overhead. So what I do is I can send or advertise a summarized version instead of individual networks. Okay, so this kind of scenarios are preferred only when you have a let's say you have some network which are still not used. Okay, so let's say you have taken up 192.168.0.0/16. Okay, and you are just going to use 4 or 5 of the networks. Now what happens is, you can rely on a broader network in case of advertising this. Okay, so depending upon the criticality, let's say the servers which are connected on these networks are not very mission critical servers, or we don't have any uh, critical device or services running on these network. So depending upon that, troubleshooting is also not very high level of troubleshooting will be involved, right? Such things you can put up inside summarization. But let's say you have the servers which needs uh, very critical involvement, or in case of troubleshooting you need to fix the issue. So in such case we never summarize the network. Okay, we would prefer sending them in single network, because then the troubleshooting becomes much more easier. But let's say if the servers were not very important, or we have some management network or management servers, so we can just summarize and we can just send it along over in the network of EIGRP. Okay, so one is called auto summarization, second one is called manual. We can set up manual as well. I will show it today. Okay, and the load balancing, the EIGRP is going to support two things. One is equal cost, other one is unequal cost. Okay, so we will do that, and the basic configuration. Okay, and yes, one extra thing about EIGRP, some latest EIGRP platform have a beautiful message called as goodbye message. Okay, so when two neighborship goes down, a goodbye message will be broadcasted. Okay, so that's nothing but just to improvise EIGRP network convergence. Okay, it's a broadcast message, which means the routing processes is shut down, and now the second router can look for the backup path, or it can look for the secondary path to reach to the destination. Okay, it's something which is a platform basis, it's not something which can be configured. You can see this on a latest version as goodbye received. Now let's say on a older version you will see something called as k value mismatch. Okay, so uh, in case of older router, if the neighborship is going down, or if you don't see goodbye message, or might be you are seeing k value, don't be surprised, it could be because of goodbye message, which is not a backward compatible. Okay, so that's why some of the older platform will misinterrupt with k value mismatch. So you need to just check what is the neighbor relationship, if it's up or down. Okay, something which is enhancement feature. Okay, it's not any operational or any functional feature, it's just a enhancement done in the case of EIGRP. Okay, now regards to the lab, I have few labs mentioned over here. Okay. Okay, so the first lab here is to show the difference between a classic mode and a named EIGRP. Okay, so I'm going to show you two things. So let's say from my network diagram, I just take the console of these devices. Okay, so just let me reload so that the config can be flushed out. Okay, so what I'm going to do now is I'm going to configure classic mode here, the numbered mode, and on the second side I'm going to make use of a named EIGRP just to make sure that you still can have a EIGRP neighborship between a classic and a named EIGRP. Okay, and the same time you can also see how a named EIGRP configuration is configured. Okay, fine. So my routers are up. I go to conf t. I go to interface. So the interface taken up here is 0/1. Okay, so this is the interface considered E0/1. Okay, I go and define the IP address, the basic requirement 192.168.10.1 no shutdown. I go to the second router, conf t interface E0/1, IP address 192.168.10.2 no shutdown. Okay, so I can just quick check if my neighbor is up or not. Okay, so it's up. Now I can configure EIGRP. So the commands to configure EIGRP is router EIGRP. What is the autonomous system? In the case of numbered format, this is how we configure. Okay, and I can just advertise the whole network 0.0.0.0. Fine. So these are the two commands required to start the multicast IP. Okay, so let me take the Wireshark over here, Wireshark capture. So you can see there are EIGRP packet initiated. Okay, so I'll just grep it. So who is initiating the EIGRP packet as of now? Only the Tokyo R7 router, the 10.1 router. Okay, so the source says 10.1 and where is the destination? It's pointing towards EIGRP multicast ID. Okay, so where do you expect this? It will be enabled once you enable EIGRP on the second router as well. Okay, so this is a hello packet, one among the 5 EIGRP packets. Okay, you can see the hello packet under over here. And what is the hello packet consisting of? Let's see that. So Cisco EIGRP, so it's going to consist of all your details like version, hello packet, the authentication flags, okay, the sequence number, acknowledgement, virtual ID, autonomous system, the parameters. You can see the parameters. Okay, so there are different types of parameter, hold timer, and all your packet types. This follows a TLV packet type, which is type length value kind of packet type. Okay, so this EIGRP packet is only originating from one side. The reason is we just have enabled EIGRP only on this router. Okay, so there is no neighborship still forming because this doesn't have EIGRP yet. So once I enable EIGRP, it will also trigger up the hello packets, and then you know what happens. So first packet is multicast. As soon as multicast hits on this, this is going to send the complete routing table via unicast. Okay, and then it's going to reply back with the acknowledge packet, and then it's going to send its own routing, its own hello packet. Okay, so what I'll do is I'll just enable debug here. So do debug IP EIGRP neighbors. Okay, so I have this debug enabled. Let me also enable over here. Fine. So what I'm going to do is on my second router, I'm going to make use of the named EIGRP configuration. So let's go to router EIGRP. What name should I give? I can give it anything. Let's give it as name 1. Okay. So now it takes me to config router. Over here, I'm going to make use of address family. What kind of IP I'm going to take up? I'm going to take up IPv4. Okay. What is the autonomous system that I'm trying to build a neighborship? It's 100. Okay. Now let's define the network. So I'm going to say whole network. Okay, that's all. That's your EIGRP configuration, and it says it has found the adjacency, or it has found the EIGRP relation between another router. So let's see from the Wireshark capture. Do we see hello packets from both the end? So you see it was all from dot 1 so far. Okay, as soon as you enabled on over dot 2, okay, they started forming neighborship. Okay, so what is this packet? It's a update packet. Now let me tell you what happened here. So as I was telling, one of the router is going to send the multicast packet, and then you will get two packets. One is the complete routing information, okay, from which is a unicast packet. Okay, and this is nothing but the update packet. So whenever there is a routing information sent, it make use of a update packet, and that's how it received on R1. R1 is now going to send a acknowledge packet. So do you see acknowledge packet over here? Right, so you have update packet, which is the complete routing information. You have one more update packet. Who is sending that? It's your 10.2, which is sending the update packet, and then you will have the acknowledge packet, and then they form the normal neighborship, and then the hello is just something which will be exchanged every 3 seconds by default. Okay, so that's how this neighborship formed, and that's what happened in the backend. So I have documented those neighborship topics. Okay, so if you go back and you just follow the theory, you will understand what I'm exactly trying to say here. Okay, so this is what is happening. First, hello packet from R1 to R2. R2 will send the complete routing information, which is a update packet in this case. Okay, your update packet will carry the routing information. It's mentioned here, and that's unicast in nature, one to one in nature. Okay, and then router 1 is going to send another unicast, and it's a acknowledgement packet. So once after these three steps, your hello packet will be sent from R2 point of view, and now R1 is going to send the complete routing information, and then R2 is going to send the acknowledgement. Okay, so this was the initial neighborship establishment process. Okay, so once we have done this lab, so what does it prove? We have one side number EIGRP, and on other side we have named EIGRP. So that's fine. Okay, so we are good with we are good with these two things as of now. So let me see my EIGRP neighborship first. So I have the handle. H is nothing but handle. I have only one known route. Okay, so it's designated with number 0. So this is my neighbor, this is the local interface, and these are all other components which we discussed in the case of neighborship table. Okay, so let's move to the second lab. Okay, so the first lab was to check the neighborship between classic and named mode. Now let's see in the second lab, are these k values going to hamper our neighborship relationship? Okay, so what I'm going to do is I'm going to manipulate the k values in such a way to make sure the neighborship still remain good, or it's going to break down. Okay, so how do I change the k values? It's over inside the router process. So let's say I'm on the first router. Okay, so over here I just have to configure the k values, but before that let me show you what is the default k values. Okay, so by default these are the values taken up, and if I show you the same thing on my second box, okay, so this is what you see. So they are same. Okay, k1 and k3 are 1, rest are all zeros. Over here you see k1 and k3 are 1 and rest are all zeros. Okay, so now what I'll do is I'll change the metric value. So the command is nothing but router EIGRP 100, and I can just change the metric value. Okay, so metric weight. Okay, now it's asking me for TOS. Okay, it's asking me for TOS. Now what is TOS? TOS is nothing but type of services. If you just go to IPv4 header format, there is a component called TOS. Okay, type of service. Do you all see this? In the case of IPv4 header, we have a component called TOS, type of service, which is a 8-bit or 4 bytes. Okay, so this is the first component that's been asked over here when I'm trying to change the metric, but by default EIGRP is only supporting 0, so I don't have much option here. In the next, it's going to ask me to configure the k1 value. Okay, so what I'm going to do is I'm going to manipulate the k1 value as of now. So what is default value? It's 1 here. Okay, so I'm just going to put it as some other random number, so let me put it as 0. Okay, what is the next value that it's asking me? It's asking me for k2, and what is the k2 value? It's 0. I'll just keep all other value as it is. Okay, k3 will be 1, so let me put it as 1. K4 is 0, k5 is 0. Okay, and now I'll trigger this. I'll trigger the changes on my k values just to make sure the neighborship are dependent on these k values or not. Okay, because from my packet level I see the hello packets are going to carry the k values. Agree, they're going to carry k values. So I just want to check what happens. So as soon as I change the k values, my neighborship went down. Okay, and that's obvious reason. The neighborship will go down as soon as the k values are different for two uh, EIGRP routers. The neighborship will go down. Okay, so you can see the peer termination. So they are carrying some random values now because there is no neighborship as of now. Okay, so you will see the neighborship has gone down now. See, the k value has changed to 2. Okay, so that proves that the lab 2, in the case of lab 2, it proves that yes, mismatch of k will bring down my neighborship. So I just have to fix that. If I just put it back to 1, it will bring up my neighborship. Okay, so that's how I just got my neighborship. Show IP EIGRP neighbors. Okay, so I have a neighborship up since last 16 seconds. That's a good thing. Okay, show IP EIGRP neighbor. Well, so neighborship are up. Fine. So the neighborship are dependent on k values. So don't change them. If you are changing, make sure you change it on both the side, or else they are going to break. Okay. Regarding to the route summarization. Okay. I just told you I'm going to show you how this route summarization works. So if you see the routing information or the routing table as of now. Okay. So let this come up. Okay, what I'll do is I'll just enable some EIGRP on other router as well. Okay, so let's say I think I have the interface configuration here. So for Tokyo 29, this is the configuration. This is the interface configuration for Tokyo 12, and similar way I have interface configuration for Tokyo 30. Okay, so let's see from EIGRP point of view. So let's see, do we have any routes installed here? Okay, looks like they are just coming up. So let's give it some time. Okay, so for some reason they are not coming up, might be because these are pre-configured. Okay, they were configured with some values. I'll just restart and I'll just configure. Okay, so looks like the EIGRP was missing. Okay, so I'll just configure EIGRP here. Router EIGRP 100 network 0.0.0. I have router EIGRP 100 network 0.0.0. Router EIGRP 100 network 0.0.0. So this is my interface configuration for the first router. So let me put that and let me go to the EIGRP process and I am going to enable it up. Okay. So now let's see, do we have the EIGRP routes? Okay. 40 and 20. Okay, so that's 40 and 20. What about R10 in that case? Okay, 10.1. Okay, fine. So I'll just show you what is summarization at this moment. Okay, so if you see, you can see multiple networks, or you can see the whole 30 network advertised in a single route. You have a 50, you have 60. Okay, so what I'm going to do is I'm going to consider my interface. Okay, so let's say I have the interface 10.0, okay, which is a class C network /24 network. Now let's say I want to summarize this in terms of /16. So I can do that. Okay, so I can summarize in such a way that I start advertising the broader network instead of 10 dot. Okay, instead of a class 24, I can summarize into like /21 or a /16. So what I need to do is I go to config t, I go to interface E01, I say IP summarization address. So it's going to support two type of protocol. So I am taking up EIGRP. What is the autonomous system? It's 100, which is advertised. What is the network? So I'm going to advertise 192 168, and let's talk about 10.0 255 255 248.0. Okay, now this is not an class C, so this is an example of class a different subnet mask. Okay, which is not a class C. Okay, so basically class C would have been this 255 255 255.0, but I'm taking up some other network as of now. Okay, so this way I just summarize this, and what happens is it says there was changes done and it's resyncing up. Okay, and if I see the routing table now, so you can see a new link being put up. Okay, and you can see the 30.0 over here. So basically what is happening is, so if you remember from my the class where I told you about the benefits of null. Okay, so what is happening is you were advertising /24. Now you are advertising a broader network 21. Now what about those network which are not used yet? Okay, so someone initiate a packet for such network, there will be a loop happening. Okay, so in order to avoid any loop, I am going to put my network forwarding to null. Okay, which is virtual in nature. So in this interface is virtual in nature. Okay, so the routes are pointed to null, and whatever is the actual route, that will be considered. Okay, so you will see the new route inside your routing table as soon as you have the route summarization enabled. So this is how we configure route summarization on manual way. Okay, so now let's say I just take it out, I just take out the command which I just made use of. Okay, so it will go back to the original status of non auto summarization. You can check the routing table now. Okay, so you will see the null interface has been removed. Okay, so this is all the default behavior. Individual network will be considered instead of the broad network. Okay, instead of /21, okay, instead of /21, now you can see individual network getting advertised. So this was manual summarization. To enable auto summarization, that is automatic summarization, you have to go to router EIGRP, the autonomous system, and you can just enable over here auto summary. Okay, and that's going to enable the auto summary. So let me see what is the routing changes now. So if you see now, what network am I advertising inside EIGRP? Show IP run section EIGRP. Okay, so I am advertising 0.0.0. And if you see the routing table now, show IP route EIGRP, you will see a new route being placed to 1.0.0.0, which is facing to null. That's because you are advertising by default this network, okay, and you are summarizing this network. So any valid IP that starts from 1, agree, there is nothing which starts with 0. Any valid IP starts with 1, so that's why it's summarizing the complete network, okay, class A network. So that's a behavior of summarization. Instead of advertising individual links, okay, you are just compressing the whole thing, okay, you're going to compress the whole thing and you're going to advertise that on a wider subnet mask like /21, which will carry all other networks. So you don't have to advertise each one of them. This is basically done to uh, shrink the routing table, okay. So basically your routing table will decrease by a lot of entries. You don't need 100 or 200 individual entries on your routing table, which is complicated during troubleshooting, right? So with the help of summarization, let's say 10 of the individual links get within this now, okay. So you don't see 10 individual advertisement inside routing table. It will be just one broad network which will be taking care of this. Okay, so that was regards to summarization. So let me see what else do I have. So that was summarization, auto summarization. Okay, now next lab is to prove that hello and hold timer packet is not going to hamper our neighborship. Okay, so we checked in the previous case, the K was hampering, the K was impacting the neighborship. But what about hello packets, the hello timers, okay, the hello timer which is a part of hello packet, okay. So you see there is a hello timer mentioned here, the whole time is mentioned here, and you also see there is a hello packet or the hello timer mentioned there. I'm going to change the behavior of that, okay. So I go to the interface E0/1, I say IP hello interval EIGRP. What is the autonomous system? 100. And what is the hello timer that you want to change it to? Let's say let's put up as 10 seconds. Okay. Let's see for the new packet. Hopefully the new packet will now start taking up 10 as the hello timer. So this is 5. Okay. So let's also try to change the hold timer. Okay. I'm going to change hold time EIGRP of autonomous system 100. Let's put it as 30. Okay. So as you can see, there the whole timer has changed now. Okay. It started showing as 30. On other side we have 15. We have 30, 15. Okay. And regarding hello packet, it's still showing as 5, even though we just changed that. Okay. So let's see from the neighborship point of view. Do we have the neighbors established? So which is that neighbor? It's 10.2, right? So yes, we still have neighborship established. Okay. So changing hello and hold timer in case of EIGRP is not going to bring down our neighborship. Why I'm focusing on these points, sir? In case of OSPF, the behavior is different. Okay. The change in hello and hold between two routers will bring down the neighborship. Okay, that is where you will get your confusion started up. Okay, in the case of EIGRP, there is no need your hello and hold timer must match. That's what we did a lab now. Okay, you just change the timer on one side, and the other side still reflecting the default timer. There was no change in the neighborship. Okay, well, so let's go and check the next lab. Okay, one thing about here is you can change the hello timer, but don't change the hold timer or the dead interval. Okay, the Cisco don't recommend changing up hold timer. It's a best practice not to change the hold timer. Okay, so keep the default value. In the case of Ethernet, is 15 seconds. Okay. Okay, how do we configure the event logging in the case of EIGRP? Okay, what is event logging? So let's say there was a neighborship down, there was a addition of new routes. So events will be generated on your box, which will be saved on some external syslog server, right? So you need to enable some features which you can enable by going to EIGRP 100, and you can just enable this by EIGRP. How many event size do you need? So you can set it up 100 events. You need it always at on your router. Okay, similar way you can have configured EIGRP log neighbor changes. Okay, so what kind of events are you trying to generate? So you are going to generate the neighbor changes. Okay, similar way you have neighbor warnings which you can enable. Okay, so as of now I'm going to start log neighbor changes. Similar way I can start EIGRP log neighbor warnings. How many or what is the interval that you want to set? Don't be very critical, because then your router will have extra overhead uh, by having very critical timer. Okay, so set something very reasonable like 10 seconds or something. Okay, so this is how we configure the events. Now what happens is, in future whenever you are logging to your box, let's say this box, you will have so and so many events accumulated and be visible to you guys for your troubleshooting of any previous week or 10 days or 15 days uh, back. So you can just have this. Okay, and let's say you have some external syslog server, you can point this device. Okay, you can just point logging server loggings. Okay, let's say you have a logging external logging server on a Linux box or a Windows box, you can point it to that. Now all these logs, event logs, the neighborship logs, will be automatically sent to this external server. Okay, so that's a enhancement feature of EIGRP. Okay, regarding the next lab, which is called as split horizon. Okay, important topic. What is split horizon is? Okay, I'll consider this as a reference diagram. So we know there can be looping possibility in layer 2 as well as in layer 3. In case of layer 2, how do we prevent looping? By enabling spanning tree. Agree? And what is a loop look like? So in case of a switching platform, when you have two interface, the Ethernet packet can just revolve in a circular fashion. Okay, so whatever Ethernet frame was sent to this interface, this will broadcast back, and that copy of Ethernet frame will reach here. Again it is going to be broadcasted. Okay, and that's going to be causing looping issue in case of L2. In case of L3, it's again a loop scenario. Okay, so what happens is, let's say I have few routers. let's say a network was learned from R1. R1, it's 1.1.1.1. Okay, you are advertising this network, and the same network, let's say, is connected to this router as well. Now the same network, your R2 is also going to advertise to R1. Now there can be looping happening here. Okay, so if you see from this diagram, this user machine which is advertising its network 10.0.0.0/24, it went over on this. Okay, now once you enable split horizon, it says that don't re-advertise the same network back to the interface where this network was learned. Okay, so any network, let's say in this scenario, from R1 point of view, which interface was this network being learned? It was learned on this network, right? On this interface F0/0. So the enabling split horizon says don't re-advertise the same network once again over on this interface, because that's connecting to the R2, and then it's again connecting to R3. Okay, so what would be the scenario in case there is a looping here? So if you do a trace route, you will see the packet will be just switching around here. Okay, we saw in one of the scenario, when you see the trace route will be just between the two routers. Okay, because over here whatever you're advertising will get into loops. Okay, so to avoid such loop, in especially in L3, we make use of split horizon concept. And what is this going to do? So it's going to say don't send the update packet and your query packet on the same interface. Okay, so whatever update packet that you're sending over here, now don't make use of this interface to send the query packet. Now why does it say that? Because update packet is for the new connection, or let's say the new or the primary connection. When is the query packet sent? To find out the backup connection. Okay, so they are two different things. One is the initial connection or the primary connection. Query packet is used for establishing the backup connection. Okay, so they cannot be sent on the same interface. That would create a loop if we send both of them on a single link. So that's what the split horizon is going to do. When you enable split horizon, it will make sure the EIGRP update and query packets are controlled. Okay, and controlled in such a way that they are not sent to the destination where the interface is the next hop. Okay, in this case, from R1 point of view, who is the next gateway? This is the next gateway. So your query and update will be not sent over on this link. Okay, so that's what the split horizon is going to do. So how can we enable this? So by default this will be enabled. Okay, so you don't have to worry. By default the split horizon will be enabled, but yes, you can also turn it off and you can also enable this. So you just have to go to the interface. So let's say from R29 point of view, this is the interface E0/2. Okay, and just you can just configure IP split horizon EIGRP 100. Okay, this is to enable and this is to disable. If you put up no, this is going to disable. Okay, as soon as you disable, you can see the new packet saying that there is a resyncing happening and the split change horizon will be considered. Okay, so that's how the split horizon is enabled and disabled. Okay, and what is split horizon going to do? It's going to prevent the L3 loopings, especially in the case of distance vector. Okay, the case of distance vector, we don't need R1 to carry the update packet and query packet on the similar link, because those two packets are responsible for two different things. Update is for your primary relation building packet, and query is when primary is down and then you send the request for backup. Now when this link is down, why should you send the second or the backup link over here? Now that can cause the looping, right? When, let's say, this the initial links also comes up and you have the second link also forming up neighborship with this. Now that's not a good thing, right? So we are enabling split horizon so that this behavior is changed, and the interface take care of these two packets. Okay, so that was a small part over here in case of EIGRP. So let's see what is the next thing. Okay, so next thing is regards to equal load sharing and unequal load balancing. So by default, the equal load sharing will be enabled. You don't have to worry, but I'll still show you the few things that can be done here. Okay. So let's see. Let's go back to Tokyo's R7. So let me see if I have the neighborship up. Okay. So I have the neighborship up. Okay. So what I just need to do is I go to router EIGRP 100. Okay, to have equal load sharing, I'm going to say traffic share balanced. Okay, so when I do this, it's going to make use of proportional balancing. Okay, this is for equal load sharing. I can also define the path. Okay, so let's say I need maximum path to be 3, or let's say I want only 2 to be the maximum path. Okay, so by default it's 4, but yes, you can change it up to 32. That was discussed in the theoretical part. Okay, by default your EIGRP is going to consider 4 equal load sharing, but we can change it to 1, we can change it to 32 as well. It's not going to uh, not violate the properties. Okay, it's something which can be manipulated. So this is how we change the equal load sharing, or we enable the options in case of equal load sharing. Okay, so by default it is 4, but we can make it up to 32. Fine. Now regarding the unequal load sharing, so let's say I go to router EIGRP 100. Okay, so what I need to do is I just need to enable one command which will enable unequal load cost sharing. Okay, so I'm going to say variance as 2. Okay, now this is going to enable load sharing, but how is that going to enable load sharing? Okay, so let's say when I enable it as with the command variance 2, how is this going to support unequal load sharing in the case of EIGRP? Okay, so always remember this unequal is only supported in the case of EIGRP. OSPF is not going to support. And how does it do? So I have a very good diagram with me. So let's say I have I just need to push a route from router E to router A. So this can take this path, it can also take this path, or it can also take this path. But from the metric I see it is 10 plus 10. So the preferable route would be this one, that is ECA. Okay, router E, router C, router A. Now let's say the next best path here was 20 plus 10, which is 30, and then you have 20 plus 25, which is 45, which is the last preferred one. So 20, 30 and 45. Okay, So by default it's ECA that's taken up. That's genuine reason. Okay, now for some reason I also want to have my second best second or the second feasible successor to be acting as a unequal load balancing. So I need my packet should take the second path also along with the first path. I'm not saying that to disable this and allow the path from router B. Okay, that is not my requirement. I'm saying that along with my primary, I need this to be taken up this as well, which is nothing but unequal load sharing. Agree? Because ECA has metric of 20, EBA has metric of 30. Okay, so what you going to do is, or how you enable this is, you just enable variance. Okay, the moment you start in a variance with 2, what it is going to do is it's going to say this is the best metric. Agree? Which is 20. If you enable variance of 2, now that becomes 40. And why do you do this? Just to make sure any route which is below 40 will be part of distribution or route sharing or the load sharing. Okay, so in this case this is 30, which is lesser than 40, which is lesser than whatever variance you started. Let's say the variance was 1, okay, which should have resulted in 20. Now this or the next route will not be acting as a unequal load balancing. Okay, only when you put a variance of 2, now resulting value will be 40, and you have the second backup primary link or the second backup link which has a metric of 30, which is smaller number than the variance number. Okay, that's how you will see the two unequal load sharing routes. Okay, so let me see if I have that. Okay, you don't. Okay, let me try to recreate it on my lab. Okay, so let's go to this. Do I have any load sharing? Okay, so I do see there are load sharing happening. Now it's this is a equal load sharing. Okay, the same cost. So 40 network is considered, this network is considered, and you have 20 or as well, that is this direction. Okay, but yes, this is also possible only because there is some configuration done as of now, so this is not taken up. But yes, we can have 3 routes installed in my routing table. Okay, so we can do that. So this is a equal load balancing. I'll show you the variance command here. So let's change the interface bandwidth. Okay, so let's change the bandwidth of interface E03. Okay, so let's put it as 100. So if I do see interface bandwidth now bandwidth will be reduced. Okay, bandwidth has been reduced. What is the bandwidth of the first interface? So the first interface is this. Now let's see what is the how is the route behaving now. Okay, so now you can see the second best path has been taken down because of the metric. Okay, so from the topology table we can see what was the metric given to that. Okay, so which network was that? 20 network, 20. So you can see the metric has changed now. Agree? By playing with variance, we can still bring up the second link, that is 20 link. Okay, by playing with your variance I can still bring this network, which now is not put up in the routing table because I just changed the bandwidth of this interface. Okay, changing the bandwidth will change the cost. Okay, so let's go to router EIGRP 100. let's say variance as 10. Okay, just to make sure I have it done in a right way. And what is the topology now? How about I change the variance still 100? Okay, now what does it say? Common unequal ratio of unequal path weighting prevents one of the adjacent from being used. Okay, so the variance 100 fix the issue for me. So I believe I have a unequal load sharing now, which we can check it now. Okay, and yes, you can see that your EIGRP is going to support unequal. This is a different metric, but yes, as you change the variance, you still have the second route taken up, which is over on 20.2 network. Okay, so that's what I was trying to demonstrate here. By default, equal load sharing is happening, but yes, you can also change the behavior and you can bring up your unequal path. Okay, so that's a good thing about EIGRP. Now this features we don't have in case of OSPF. Okay, so let me go to the next lab. So I just covered the load sharing part. Okay, fine. Now the next lab says about passive interface, which I guess you guys should be knowing about. So what is passive interface? So let's say I have multiple routers. Okay, so I see the network was going in this way, and there could have been written or a packet coming back to this. Okay, R1 or something like that. So suppressing EIGRP packet can help me here. Let's say I don't want this interface participating for EIGRP packet, so I can put this interface on a passive mode. As soon as I put this on a passive mode, my EIGRP packets will be suppressed. Okay, so I can show you that with the help of packet tracer also. So let's see from our 12 point of view, let's see which interface has EIGRP neighborship. Okay, so it's over on 0/3 and 0/2. Okay, so let me bring this interface to passive mode. So what I'll do is I'll first take up the capture. So I'll just turn off from the upstream side. Let's say from 0/2, I'm just shutting it down. The reason why I'm shutting down this side is I don't want the packet, the Wireshark showing me the hello packet from this side. Okay, it will lead me to some confusion. So I'll just try to show you the behavior of passive only. So if you see now, you will be seeing the hello packet only from 60.2, that is from this. Okay, and this is the interface which I'm going to place in the passive. So the interface which is shut down will of course will not send any EIGRP packet. But when you put some interface on an passive, what's going to happen? Will it still trigger up EIGRP packet, or the packets are going to get suppressed? Okay, so we are going to check that. So I go to interface 0/2. Okay, I'm going to say IP. Okay, so what is the command for passive? It's okay, so I don't have to go to interface. I can go to global EIGRP configuration, and over here I can say passive interface E0/2. Okay, and let's see the Wireshark. So what is happening is the interface is sharing hello packet, okay, on which interface is this? This is, oh sorry, I need to put this command on Tokyo 12, okay, that is this. So on this interface, on this router, I go to router EIGRP 100, that is the autonomous system, and I put the passive interface E0/2. So do we have any further hello packets? No. Agree. So that's because I have put that interface to passive. Okay. So there are two things. Now you might be wondering, why passive interface? Why not shut down? If I make shut down, then let's say this interface, I wanted to participate in EIGRP, but I don't want the interface to send any EIGRP packet to further routers. Okay, so in that case, I cannot shut down this. I want this interface to be actively participating in EIGRP distribution. Okay, so let's say this interface has a network 192.168.1.1/24. If you shut down this interface, it's equivalent as you are taking down this whole network from EIGRP, which is not my requirement. My requirement is this network, let's say, which is E0/2 on 192.168.1.1. I just want to make sure there is no EIGRP formation happening here. Okay, I don't want my interface to carry any hello packet or update packet, because I know on the downstream I don't have any other router. I don't need to build any EIGRP relation, but at the same time I need this network to be advertised on the upstream. Okay, if I shut down, then this network will not be advertised on the upstream. Okay, I just want them to be part of EIGRP, but I don't want any relationship in the downstream. Okay, so in that case I am suppressing the hello packets with the command passive. As soon as I put into passive, they are not going to send any hello packet, but they are still participating in the EIGRP process. So that's benefit of passive command. Okay, now regarding EIGRP filtering. Okay, so there are two ways we can filter the routes. Why do we filter the routes? So basically, filtering the route is as good as ACL permit and deny. Okay, I'm just restricting some users to be part of EIGRP, but at the same time, some of the users not being part of that EIGRP group. Okay, so there are two ways I can make use of this. One is with the ACL, which is also making use of distribute type, and the other one would be prefix list. Okay, so basically prefix list and ACL are almost the same. Okay, but with the routing protocols we make use of prefix length. Okay, ACL is used in the case of switching, or in the case of ASA firewall we make use of ACL. Prefix list, it's more dealing with the dynamic routing protocol, also your BGP. So with the routing protocol you make use of prefix length, but I will show you both of the ways. Okay, I'll just show you how you filter any network to just to avoid those network getting participated on the EIGRP advertisement. Okay, so I hope there is no latency. Okay, okay, great. So let me configure the two ways to block any network participating in EIGRP. Okay, first one is with the help of access list. Second one would be with the help of prefix length. Okay, so the commands, the basic commands are as what we had already. So I need my EIGRP running up. Okay, I have the EIGRP running up. Now what I'm going to do is I'm going to create some access list. So let's say access list 1 deny, and I can just deny the network. So let's say over on this router, I have some loopback, or I have some network with 10.10.10.10, which I don't want to be part of EIGRP advertisement. Okay, so I'm going to block them. So I go and create 10.10.10.10.1 is to be denied, but at the same time I want all others to be part of this. I want to permit all other things. Now where I'm going to call this, or how am I going to call this? I'll go back to router EIGRP 100 and I'll make use of distribute command. Okay, distribute list. Now which is that list number? It's 1. Okay, and in which direction do you need this? So basically, let's say this is in the in direction. Okay, so in direction of E01. So I'm going to say in, and on which interface? So it is Ethernet 0/1. Okay, so with this kind of setup, you are blocking that 10.10.10 network, but at the same time you are allowing all other networks. Okay, this is a filtering concept. Okay, you might have heard in your enterprise or in your organization that you have 100 networks in the EIGRP, but let's say you don't need all 100. It's only the 10 network which has to be in the EIGRP. Why do you need everything in the EIGRP process? If there is one addition or deletion, the whole thing will be getting reconverged, or there will be the recalculation happening, right? So the shorter is your routing table, the shorter is your EIGRP advertised network, the process, the overhead on this router will also be very minimal. Okay, so that is the whole logic to reduce these things. The auto summarization, why did we use auto summarization? Because I don't need 10 or 20 individual network. I am compressing everything into one broad, so that everything is within that, right? That is to reduce the overhead. Similar way, why I'm using these access list, or I'm preventing the non required ones, because I'm trying to reduce my overhead on the routers. Okay, so this was one way where I made use of access list with the help of distribute command. Now same thing can be achieved with the help of prefix list. Okay, not length, prefix list. Let me show you how do I use the prefix list. Okay, so let's say now I want to block 20 dot series network. I want to block 20.20.20.1 to be participating from EIGRP. So my command would be IP prefix list. So I'm going to name it. So let's say test 1 2 3. Okay, what do you want to do with this? Do you want to permit, or you want to allow, or you want to deny? So since we have two lines here, one is to deny and one is to permit, first I'll go with the sequence number. Always make sure your deny command is on the top and then comes the permit command. Okay, the reason is these type of access lists are in a sequential order. That is, first goes and checks the first list, then it goes and checks the second list, and so on. It goes to the third, then fourth and fifth, and so on. It is a sequential order. Okay, they're not parallelly checking the rules, it's one after one. So now let's say if you have permit on the top line, everything get permitted. Okay, your deny will now not be even functional, not non-effective line. So you have to bring that deny statement on top, so that that particular network get discarded and rest all will be permitted. Okay, so that's why we make use of these access list or prefix list in a very careful ordering. Okay, so let me put sequence number. So I say the sequence number here is 5. I want to deny this. What is the denying network? It's 20.20.20.0. Let's say /24. I want to deny this. But at the same time, I have another sequence number with the permit statement, and I can just put any network. So how can I do that? Because I don't have that any word, so I can make use of 0.0.0 and the prefix length of 0. Okay, now this is going to permit. Now I just defined my prefix list. I have to call this within my EIGRP. So I go to router EIGRP 100. I'll make use of this distribute command. Okay, distribute list, and I'll say prefix. What is the word that I have used here? It's prefix list test 123, and on which direction. Okay, now this is something which could be little confusing, what is in and out. Okay, so let's say I'm talking from this interface point of view. Now if any packet is coming in this direction which is carrying 20.20.20.1, now that's something where you have to make use of the keyword in. If you are sending that 20.20.20. over on this interface to some other uh, router, now that would be your out facing. Okay, and that in that case you will make use of out. This is just a lab, this is just for showing you different combinations. So I'm just making use of in. Okay, but yes, you can also make use of out depending upon the packet flow. You need to see how the packet is actually traveling, whether it's incoming traffic or it's outgoing traffic from this router point of view. Okay, so based on that you can filter. Now this topic is actually called as EIGRP filtering. Okay, you just can take down one or two network which is actually not participating in EIGRP, but let's say that was a part of the process. So let's say we have advertised 192.168.1.0/24 inside EIGRP process, but then we realize there is some smaller network like 1.10./28, and we have 1.192.168.1.200/30 network. Let's say 6 or 10 IPs here and 2 IPs here, which don't need to be part of EIGRP. Now we can filter them. I can just exclude them from the routing, EIGRP routing. I don't want to advertise them. Now that's a process called as filtering in the case of EIGRP. Okay, fine. Let's see what else we have in EIGRP. So we done with uh, filtering. This is a prefix. Okay, and yes, we have one more option that's called as route map. Very important thing. Once again, route map is very important thing. You will see this topic in BGP. Okay, so in BGP, when I have scenarios for dual ISP, let's say one router connected to one of the ISP, another router connected to second ISP, and requirement is some of the network takes up first route, second net or the other group of network take the second ISP. In that case, you can make use of route map, you can make use of prefix list, and you can define which traffic to be taken from first point of view, and which or the remaining traffic or the remaining network should take point or should be taken up from the second point of view. Okay, so these topic like route map, prefix length are more seen over on BGP instead of what we are using right now. But yes, we see this filtering in production. Okay, in production we see some networks will be made sure that they are not advertised unnecessary on EIGRP. Okay, otherwise what happens if something, let's say you had some computers on that 10 IPs, so adding or deleting can bring reconvergence, the recalculation each and every time. Okay, which is a unwanted overhead on the devices or the routers. So that's why we filter them. Okay, regarding route map, what you just need to do here is you have to make a route map group. Okay, so you say route map you just give a name. So let's say now it's CCNP 123. On which direction are you creating this? So let's say you're just denying this, okay, and give a sequence number. So I'm going to give a sequence number, okay, route map CCNP 123, let's say deny and sequence number of 5, okay, and I just need to define my access list, okay. I have not defined access list, so let's see if I still can do that. So I say match IP, okay, address, and I can just define which network I want to be placing under the deny statement. So let's say I want to place 12.12.12.1, okay, which is a part of deny. At the same time, I will also make sure I have another route map where I have permit statement for all other traffic, and I'll place the sequence number to be 10. And within this, I can put match address as the all other things, okay, all the other network like 0.0 network, okay. So this way I define my route map, deny and permit. After that, I go to my routing EIGRP process, and I'll make use of distribute command, and I just call the route map, okay. So I have a command for that, and what is the route map name? It was CCNP 123. And on which direction? So as you know, in and out, there are two possible things, okay. Okay, so what did it say? Prefix length filter exit deconfig first. So basically that's getting overlapped with all the previous configuration. The prefix length, ACL, distribute, whatever we did, so it's just overlapping with that. Okay, so this is how we have three ways to block any network or allow any network. Okay, one is access list with distribution, prefix length with distribution, and route map with distribution. Okay, three ways. Very good thing, actually. This is called as EIGRP filtering. Okay, now the last thing over here in case of EIGRP, I guess we have covered almost everything, that is regards to authentication. Okay, so let's see what kind of authentication is EIGRP supporting. Okay, I go to interface, let's say interface E0/1. I go to IP authentication. Okay, so there is a keychain method. Also there is something called mode EIGRP, and let's say it's 100, and it's having MD5. So your EIGRP is going to support two types of authentication. Okay, one is chain type, other one is MD5. Okay, and yes, the plain text is by default, which I'm not writing up, but you should know that by default EIGRP was considering plain text. But yes, we can make use of chain, and we can also make use of MD5. I will show you the chain part, okay, which is actually not a CCNP part, but I will show you that. Okay, that's more like your CCI level, where you need to know the authentication, different type of authentication, okay, the keychain. Whereas in OSPF you still have um, the few new added up ones, okay, keychain, MD5, and you have SHA method as well, I guess. Okay, so I'll tell you which are the other methods over in OSPF. So in the case of EIGRP, I'll show you how we create a chain. So let's say I make use of key chain, and let's give some name as CCNP1. Okay, I'm going to make use of a key value. So what is this key value doing? Okay, so basically what happens is, let's say I have a EIGRP router 1, which is in a neighborship with 2, the second router. Now let's say you just bring in one more router which had some other key running up. Okay, so you just don't want to play around with the key 1 over here. Okay, so you just don't want any kind of flaps happening. Okay, so what you do is you can have the neighborship still with these two. You just have to create one more key, let's say key number 2, and let's say the same key number 2 is over here, so you can still build the neighborship here. So in this way what happens is they are still neighbor and these are still neighbor, but this and this will not form any sorts of route, they will not know the routes, okay, because they are different keys, they will not actually form any neighborship kind of thing. So that's one way to avoid unwanted neighborship or unwanted distribution. Okay, you can set up the different keys. So how key works is, first it will be taken up key 1. Now on this side it will say I'm not on key 1, I only know key 2. Okay, now it will take the second key, that is key number 2, and it will pick up, okay, because it's configured with key 2. That's why you can have multiple key 1 2 3 4 5 10 whatever. Okay, so the keys will be taken up one by one, and the one which matches up will get negotiated and they will form neighborship. Okay, so the key must match in case of forming neighborship. So let's say in this case it's key number 1. Okay, and what is the key value? That's something which I have to define. So let's say key string is Cisco in my my scenario. Okay, and now this key has to be mapped to the interface. Okay, so I go back, I say interface E0/1, I say IP authentication. So let's say it's keychain EIGRP autonomous system as 100. And what is the word that we made use of while creating a new key? It was CCNP1. Okay, so this is a one way of creating the key, and or to create the authentication. Okay, the keychain method. The second method, that is the MD5 method, it's pretty simple. You just have to, so let's say I take another interface, let's say I go with interface E0/2. Okay, so I'm not going to change my previous interface, and let's say I take a new interface E0/2. I go and say IP authentication IP authentication mode EIGRP process number or autonomous number as 100, and okay, so there's a typo here, autonomous system as 100, and what is the type of authentication I need? So basically it is going to support only MD5. In case of OSPF you will see other encryption method like SHA values. Okay, but in EIGRP it's only supporting MD5. I'm going to make use of MD5 here. Okay, still the key has not been defined, so just make sure that I'm only setting up the authentication type. Okay, so now I need to go to my router EIGRP 100, and I need to set up this authentication. Okay, so what is the command for authentication? IP authentication. Okay, let me go to interface itself. So let's see if interface will support this. IP authentication mode EIGRP 100. This is MD5. Okay, so there is a way to define the key here. Okay. Okay, what about the keychain? One second. So how do we see the keychain? Show IP EIGRP. Okay, so it says only keychain, key and Cisco, right? So well, so this can be taken up. Okay, because they are not defining any MD5 or they are not defining any other kind of encryption process. So we can take up this key. Okay, so what I'm trying to say is, if you see from interface point, I have the authentication setup. Okay, I'm calling it as MD5 authentication. Now where is the key? So the key has to be defined. Okay, so I say IP authentication keychain EIGRP 100, and what is the word that we defined? Okay, so that's CCNP 1. Okay, now let's see the interface statistic. So I have it as MD5 and I have the password within keychain. Okay, so that's password is CCNP 1. So that's how we define authentication in EIGRP process. Okay, so that's something which is defined here. Make sure if you have authentication set up on one, the same thing has to be set up across on all the other routers. Okay, so otherwise what happens, one will start advertising the hello packet over on the authentication. Okay, and the other packet or the other side will not recognize that, because that packet received will be encrypted format. Okay, so you need to have the proper password or the proper encryption method on the receiver side as well, otherwise they will not form neighborship. So if you are using it, use it across all the router. If not, don't use it anywhere. Okay, fine. So this was few labs here in the case of EIGRP. I believe you guys went thoroughly here. So let me take Q&A now. Okay, so it says, what is address family specifying? What is it? Okay, so basically this is when you have IPv4 and IPv6, you can prefer which address family. Okay, and this type of addressing is seen in the case of named EIGRP process. What is K6? There is no K6. Okay, fine. So let's see what is K6 on the router 10, right? So on router 10, if I go to router EIGRP 100, if I say, okay, so it says it's on a named format. Okay, so what name did I use? Okay, I just forgot the name. So let's say, okay, it was name 1. Okay, and address family IPv4 autonomous system 100. Okay, so this address family, it's about defining IPv6 or IPv4. I selected, I picked up IPv4, and regarding the K values, so let's say I have TOS, type of services. I have K1 which is 1, I have K2 which is 0, I have K3 which is 1, I have K4 which is 0, I have K5 which is again 0, I have K6 which is a dummy value, but yes, we can see what exactly is K6 for. Okay, so EIGRP K6. Okay, so I believe this is an additional value in case of named. Okay, so basically that is not used for in your formula anywhere. Okay, K6 is not used anywhere, but I will still show you where what is the use of this K6. You see there is nothing over here. Okay, So in the case of named mode, which is a 64-bit, you will have a K6 automatically generated, but by default it's going to be 6. Okay, so if you see the formula for a named group, or in the case of the named EIGRP, the metric will have an additional component called as K6 into extended attributes. Okay, so by default K6 is 0, and it's only when you have the named EIGRP, which is a 64 metric calculation. This will be 64. Okay, whereas in your classic method, in your classic or the number method, it's 32-bit, and you don't have to consider K6 anyway. Okay, you will not see a K6 anywhere in the classic method. Okay, so that's something about K6 here. Okay, let me go back to the Q&A. K1, K2, yes, that's in case of the classic method. Okay, all right. Okay, yes, that was true. I had not advertised the neighborship, and once I advertised it, it started taking up. Okay, classless, but auto summary is on by default. Auto summary is enabled by default, but I was showing you the manual auto summary as well. How you can configure the manual auto summary. Okay. So this is when you have router EIGRP 100 and you have a whole network advertised. Okay, I am considering network 0.0.0. That is why when I make use of the summarization, it's going to take the wide network from one series. Okay, if my network was any other values, let's say my network advertised was 192.168 1.0/24. So in this case, that would get advertised to this one. Okay, so basically what happens is multiple network, that is 192.168 2.0/24, network 192.168 3.0/24. Now with the help of manual auto summarization, I will put up all of them on this network. Okay, so this network will carry all these individual network. But in my scenario, what I'm doing is I'm going to advertise the whole wide network, that is 0.0.0. Now how is my auto summarization going to take it as 192? It could be 172, it could be 10 dot, it could be any other possible IPs, right? So what is the next, or the what is the possible IPs, or what is that starting IP? That is this IP. Okay, this IP is something which will contain all possible IPs. It will contain all 192, 172, everything, right? So in this scenario, when I'm having the whole 0.0, auto summarization or the manual summarization is going to create this network pointing towards null. Okay, null zero interface, and whatever network we define will be shown up in EIGRP. Rest of the network will be pointing to null, which will be getting dropped. Okay, null is nothing but it's taking the packet, it's receiving the packet, and it's just dropping it without forwarding it to. So do I have latency? Fine. Okay, great. Okay, so I believe I have answered this. It's about summarization. Okay. Yeah, there are two things. One is auto summarization. Okay, which deals with classful nature. There are two things: classful and classless. Okay, So by default, what is EIGRP going to do is it's going to consider class A, class B, and class C. Okay. To change this behavior, let's say I have 192, 168. Okay, not 192. Let's say I have a class B IP 172.16.23.0/24. Now, what is this an example for? This is now an example for class C, not a class B, because of the subnet that I'm using is class C. Okay. So by default, what is EIGRP going to think is it's going to think this as class B. That is this. Okay. So by default, EIGRP supports the classful nature. So in order to avoid that confusion, I normally go and put no auto summary. Okay. So that command is different. It's a no auto summary. I just want to make that as a classless behavior, not a classful behavior. That is a different concept. And summarization is a different concept. Okay. Summarization is when you have multiple network. It could be class B, it could be class C as well. So let's say I have one network here. Okay. I have second network with 24. I have 25. I have 26. Now I don't want my router to advertise individually. I just want them to be advertised in a single uh, a single network. Okay. So what is the best option is I'll put this into 16. Now this network will be pointed to null by default. Okay. And out of these whole network, the one which are existing will be pointed towards the next hop gateway as per my design. Okay. So why am I pointing all others to null? And so something like this. Okay. So what happens is these networks are valid networks, but what about the remaining network which is part of /16? There could be /27 /28, right? There is nothing in that network. So you have time being placing them under null, and the preferable ones will be pointing to the next hop gateway. Okay. So this is a new additional line that will be put up in the routing table. This is a summarization. Okay. And one which you are discussing over chat is called as classless and classful behavior of a uh, protocol. Okay. So by default it will support classful, which is as soon as you put 172.16 IP, it will consider it as class 16. Okay. So to turn off that behavior, you are going to make use of no auto summary, so that it's considered as class C only, not class B. Okay. That's a different concept. Summarization is a different concept. Okay. Yes, that's a classful network. Fine. If you don't use, yes, great. That's something. Okay. Can route map be used? Yes, you can. Okay. So that's what we checked. Yes, I will provide you. Okay. On Friday, I'll provide you for static and EIGRP. OSPF, however, will start in the next week only. Okay. So it's in a sequential order. Okay. So it goes via sequence like 5, 10, whatever. We give the sequence number just to uh, bring the newer line, or the lines which are on the top are effective lines. Okay. So whenever the matching happens, it checks the first sequence number like 1, 2, 3, and then goes to the bottom line. Okay. So if your deny statement is important and it's to deny something, so you just need to place it above the permit level, and then you need to bring up. Okay. So that's helpful when you have this sequencing kind of format. Yes. So this is address family is when you have IPv6 and IPv4 type of network, so you can create this. Okay. Okay. So if your question is which one the router would prefer, whether it's a route map or prefix or ACL. Okay. So basically you are making use of any one, not all of them. Okay. So you don't need to make use of all the three in one router. Either you are going with ACL, or you're going with prefix, or you're going with route map. Okay, so you can go ahead and make use of any one. Or let's say you want to make use of this feature on an interface basis. Let's say on this interface, all the in and out traffic you want to handle with prefix list. You can do that. Let's say you have another interface, and this interface you want to make use with the route map, so you can do that. Okay, so you don't have to make use of all the three on one interface. That is again an unwanted overhead on the device. But yes, if you want to split around on basis of interface, you can have one, each one of them. But what is preferred is keep either one. Okay, so you can go with prefix list, which is preferred in case of dynamic routing protocol. Okay, route map is when you have the path manipulation. In case of BGP and all, you have path manipulation. So in that case, you can make use of route map. Okay, so G and LE is nothing but greater than and lower than. Okay, so that's when you create some decision makers. Okay, when you have let's say you have greater than so and so sequence number, like 1023. So you can write a prefix list where you can set up some greater length, greater than so and so sequence number, or lower than so and so sequence number. Okay, so it's terms, it is from the point of defining the prefix list. So how you define them, on that basis you can make use of greater than or equal than, or else you, if you don't want, you can exclude that. Okay, so it depends on your network design, how is your network design. Okay, so that concludes your EIGRP. Let me once take up the syllabus copy. Okay, give me just a minute. And core 300,401. So just checking around whether we have completed all the EIGRP part or not. Okay, so from EIGRP point of view, we have load balancing, path selection, path operations, metrics, okay, and distance vector versus link state vector. Okay, so this was covered in EIGRP. The same thing you will also expect in case of OSPF. OSPF will have additional topic here, which includes yeah, the summarization, filtering, which we learned in EIGRP. Okay, so this was N core. Now regarding to the NRC topic, which is 350, 300, 450. So we are just following whatever is defined. Okay, but we are much more advanced than CCNP. Okay, so we are just trying to cover what is also required from CCI point of view. At least some topic you will see which is actually not part of CCNP but was a part of EIGRP. Okay, so in case of EIGRP, we discussed about address family. IPv6 will of course be covered in the future classes. So address family, which is a part of NRC. Okay, so in the case of advanced routing, we have address family, neighbor relationship and authentication, loop free path selection, which is what do you say, route distance, feasible distance, feasible FC successor, feasible successor, stuck in active, stub. Okay, stub is something which I'll tell you. Okay, so we have the stub in OSPF as well. We have we covered load balancing, we have metrics. Fine, so we have done most of them. So IPv6 and stub, I'll tell you in the next class. Okay. Okay, so that's for EIGRP. We will start with OSPF. Okay, in the next class. So what is it? It's Thursday. So we have a class today. I guess. I mean, in the we have a class the Thursday, right? It's on Friday that we cancel the class. So fine. So that's from my side. So if you have any doubt, let me know, or else we will meet up in the next class. Okay. This was discussed. Okay, this is called stuck in active. That's a scenario. Stuck in active is a scenario when your primary route is lost and your router is sending the query packet to find the backup link, and the backup link is not reachable for 3 minutes. So now this is a state when there is no route or a active route to reach a destination. Okay, so that's a scenario when you don't have any active link to reach to the destination. Okay, was there anything else put up? Did I ignore anything? Default route EIGRP. Okay, so in case of default route, so basically what default route is, in the case of summarization, what was happening? It was injecting a new route. Agree? It was injecting a new route on your routing table. Okay, so this additional route is acting as a default route in our scenario. Okay, so that's how the auto summarization works. It's by injecting a default route to the next gateway. Okay, so guys, that's all from my side, and I guess we are all good with EIGRP. Okay, so I'll give you the assignment for the weekend, as usually how I give it whenever an weekend comes up. Okay, so expect the same thing for static route and for EIGRP. You will get some assignments from my side, and please work on that, and we will discuss it on Monday. Okay, fine. So I'll just wind up for now, and we will catch up in the next class. Okay, have a nice day and see you all soon. Okay, bye.